Hey everybody, we're studying heat transfer this week, so we're looking to see what happens to materials when we add heat to them. We know there's two things that can happen, like when we put water on a stove that can absorb heat and the temperature can rise, or if it gets hot enough, if it gets up to 100 Celsius on the stove, it'll go through a phase transition, it'll start to boil. We want to be able to model the heat response of the material when we're away from a phase transition. It means when the temperature is rising, and also to model what happens to the material when it's boiling. So in order to do that, we need to get some data on the temperature response versus the amount of heat added. And to do that today, I've got the Pasco steam generator apparatus. It's really an aluminum canister that's hooked up to a heater. You can see it's down here. We've got the usual settings, low to high. So you just power it up, heats up your sample. We've got some water in there, and this is our vernier temperature probe that we've used before. It's hooked up to the LabQuest device, which is in turn hooked up to a PC running the LoggerPro software. So this will give us a recording of the temperature versus the time. And in this case, assume that we're adding heat to the material at a constant rate through the heating apparatus. So a plot of the temperature versus time is really essentially the same as a plot of the temperature versus the amount of heat added. So we're looking for what's the functional relationship of the temperature versus the heat added when we're away from a phase transition, and also what happens during the phase transition when we boil. So we're going to heat our sample up, and this was already been heated up actually. It's been heated for about 40 minutes now. So we'll get you to take a look at the data and see what you can make of it. Okay. And remember, we need two models. We need a model for what happens when we add heat to the material away from a phase transition, and what happens to the material during a phase transition. We need both of these things to study the latent heat of fusion for ice, which is the second part of our experiment. The second part of our experiment, we're going to put ice along with a warm water bath and a calorimeter. We're going to melt the ice and figure out how much heat it takes to melt that ice. And in order to do that, we need to understand first what happens to the water bath, and that's what we're looking at here. Okay, so good luck and enjoy.